Hi. Hi, everyone. Maybe, sorry about it. Hi. Do you find I've got a new place to do the lecture today? The place that you miss very, very much, right? Can you see that? Yes, that's right. Classroom. Canteen. I'll just come back to canteen because last time my neighbor has just done renovation and very, very noisy. I can do nothing but just come back for the lesson. So I just want to double check if all of you are here or just 12. Oh, sorry. Anyway, I need to do attendance. I need to take the attendance. Hi. So yes, that's right. Trần Kiến Hey, where are you?
Hello.
Hi, Trần Kiến Hey. 做咩啊？Don't come, please. 點啊 ？What happened? 點啊 ？I didn't wear face masks. I didn't wear face masks. I didn't wear face masks. You say further up, please. 真係麻煩。Hi. 知道。係咪錄緊嘅 ？Yes, yes. Yes, it's under recording. Okay. Crazy guy. Now, and can I have some others? 蔡仲常 are you here? 蔡仲常 ，Hello， 蔡仲常 ，No。唐家浩 ，where are you？
喺度啊。
Yeah， 黃俊浩 are here。And 陳浩希 ，not here。Okay， 張家榮 here I see。何展鵬、林家齊。
早晨啊，Sir。
係林家齊 ，No， 林家齊 is not here。麥耀南，哦 ，he didn't come back。好，潘樂之。
What？
潘樂之 ，where are you？
喂，早晨啊！
係潘樂之 ，where are you？No， 潘樂之。no 潘樂之。林家齊 not here。蔡仲常 here and who？ 朱俊熙 ，have you all come back？ 黃俊熙、鄭群威、陳志軒 ，where are you？ 陳志軒 ，no 陳志軒 ，and 陳龍王，仲要翻陳龍王，郭立恒 ，where are you 郭立恒 ？Is it 郭立恒 ？Yeah。and 潘志軒，skip lesson again 潘志軒，死硬佢。So this is attendance for Friday, and just have a continuation of yesterday, and we have got. Now I would like to show the page to all of you first. We need to continue. Oh, where are you? Yes. Do you see the page? Now we would like to give you this one chapter 21. Can you see that? Yeah. Yeah. Okay. So we need to continue on the past structure type questions, and I will give you remaining time to wrap up for these two chapters. And next week, we need to talk about the last chapter. It is for important organic chemicals. Now, turn to your book, page 187. We continue on this. 郭立恒, you just skipped most of the lesson. I didn't see you last time. So can you manage to answer this question? Question number 21A. Hello. You just say hello without saying anything. Now we have got cyclohexanol. They will undergo what type of reaction? It seems something has been given all right, driven off. What is that? What happened to you, Chen Kinghei? Chen Kinghei, you want to answer, right? Tell me, what is that? Hi. H2SO4 consol, yes. What is the condition? Heat, yes, that's right. Type of reaction, please. What is that? Dehydration, yes, that's right. Dehydration. So in an experiment, the student obtained this cyclohexene. Now the market is 2.86 gram from 4.05 gram of cyclohexanol, 4.05 gram of cyclohexanol. Calculate the percentage yield of cyclohexene and give a reason why the percentage is not 100%. This is what percentage yield. From this reaction, you may find what is the mole ratio of the reactant and product. That is 1:1, right? 1:1. So how would you get the percentage or how would you get the answers? Now these two data may not be in line, right? Now you have to calculate the number of moles of these two respectively. So molar mass for cyclohexanol is 100. So 100.0 gram per mole. And we have got a similar calculation, cyclohexene, 82.0 gram per mole. Okay, and so what is the number of moles? Now these two, they are different, right? The number of moles of cyclohexanol and number of moles of this one is a cyclohexene is different. Now you need to add one more term here, which is which is theoretical. Theoretical number of moles. Do you see what is the mean by theoretical? Now something that you can generate a maximum number. Okay. Well, we've got the other two. Marcus and Salomon, you will be the next one to answer the question. Now, so you may find these two. You may find these two, and you need to calculate the number of moles of those. We are now in question 21. So you may calculate different number of moles of cyclohexanol, and theoretical number of moles of cyclohexene is different. So what is the difference in mole? For cyclohexanol to be used is about 0.0. This one. It's about 0.0405 mole. Now theoretically, you may get it at 0.0405 mole. Can you get our point? So it is something that we can get it theoretically. But you calculate this equation formula 2.86 over 92.0 gram per mole. Okay, so what will you get? What will you get? 2.86 divided by 82. So you may get it as 0.0348. So something will not be reacted, right? You may find that this something will not be reacted, 0.04349 mole. So you may find you have got a huge difference between the two. Now, what is that? It's not theoretical number of moles. It is actual. So all of you, please mark it down. This is actual number of moles of cyclohexene to be produced. So when you calculate the percentage yield, it is the actual number of moles of cyclohexene over theoretical. Okay, over theoretical yield times 100%. So this is what you may get. Okay, so yeah, sorry, and so what we may get is just 80 something, as what Benzo has been stated, 86.1. 86.1. Question? Okay. Reason why? How come the percentage is not 100%? Anyone who can help? There are some reasons. How come the yield is not 100%? 張嘉文 Hello. Oh, left. You just come here and mark it, and just left. How about the others? Marcus Lam. I would take Zhang Gaowing's to be absent, right? Because he doesn't respond anything. Yes, chemical loss due to what? What is mean by chemical loss? Can you elaborate more? Yes, mechanical. Due to the mechanical transfer, there will be some chemical loss. Okay, yeah, some of yes, that is 0.1, 0.2. Evaporation. Evaporation where? Where we will get the evaporation? What is mean by evaporation? During heating. So do you know the way to do this experiment actually? Do you know? Is it undergoing, is it heating under reverse? Simple distillation, I think. Not really. So how you carry out these experiments? Somebody you do distillation, but before that, you should add consol, right? The setup should be this one, I add consol and I distill the product because this one has a lower boiling point, is it? Okay, so for this type of reaction, the chemical loss due to evaporation is not a major contribution to the low yield. Okay, because for the whole setup, of course, the chemical will not have any leakage. So your condenser should be cool enough to condense those liquid. What else? Now, besides this one, about the separation, right? During separation, you may think of like this. During separation, there were some chemical loss. What else? To name a few. And you may get some other answers, just like the reaction is not complete. Do you know why? It's not complete because I add one chemical, Consol. Now, why do I need to mention Consol? It's because Consol will, once I react with this, they will go back to the cyclohexane. But at the same time, because of the exit, I can also go back to cyclohexanol. So this one, they will give the reaction having not 100% yield. So how will you tackle the problem if I don't use Consol? And when I want to increase the yield, I change another acid to accomplish the same task. This one is not so it's not so appropriate. Well, if you are aiming at higher yield, they will use what? Okay, I will use concentrated phosphoric acid. Okay, so any questions? Yeah, okay. How about question 22? Now something about calculations. Again, you are going to calculate the percentage yield. You are given molar mass, very similar to what you have done last night. So what is that? So again, you are going to find out the number of moles of the two substances. Okay, one is the reactant, one is the product. So you may get the reactant side first. Reactants, you are going to find out number of moles of the reactant. The tertiary butyl alcohol. So you may get it as, it's quite difficult, right? This time I would use the volume to calculate, right? The volume. So you have to make use of the work density to calculate. So how will you use that data? Okay. Pencil, you should not have any lag because we are using the same lag, right? Tell me, how you calculate? Yes. What is that? 0.84. Here, this one. But you are going to have methylpropane 2 is 50.0 cm cube. What are you calculating? So this one, how you cross M out those units, so you just get mass, right? The mass of the reactant. So you are going to divide it by the molar mass, 79.0 gram per mole. So you may get the number of moles, 0.161 mole. Can you calculate? And which is equal to the theoretical number of moles of the products. Okay, the products CH3 bracket 3CCl. Okay, so this is the theoretical yield. So of course you need to calculate the product side. Product side, I need to get the actual yield. CH3 and then brackets 3CCl. So it is the actual number of moles of this one produced, the chloral product produced, which is equal to what? 6.9 cm cube, and then times 0.84 gram per centimeter. You multiply it together to form mass. Over is molar mass, is 92.5 gram per mole. By doing so, we will get the number of moles of the product to be formed, which is what? Which is what? Number of moles. So what is that? .9 times 0.984 over 92.5. So what is the number of moles? Is it 0. What? Yes, 0.0627, right? If you just take a look at the calculator, but you may find it is 6265 something something something. So you use this data over the denominator, so you may get the percentage yield, which is equal to 0.0627 over 0.161 mole times 100%. What will you get is the percentage yield. It's very low yield. What is that? 39.1, yes, percent. So this is what you know it yesterday. You may find we have a very large coverage on doing some separation method to get to know some of the details in between. You may know some of the procedures, and finally you are asked to come up with the calculations part. So the calculations part involve the mole ratio, the concept mole ratio again. Okay, so far, do you have any questions? No? Really no? Now, if not, maybe you may see some more questions about. Now, I can show you some more questions about conversion as well as the lab preparation of the organic chemicals to end up the lecture today, because it's just a wrap up for today. And could you please take a further look on the topic exercise? Topic exercise is far at the back. Far at the back. So you may find those at the very back. What is that? That is a topic exercise. You turn it to the book, page very near the end. 224. Can you see that? 224. 224. Now, shall we take a look on the MCs? Or you want to do long questions? Or you want to do the synthetic pathway? Which one? Both? Try to see if you have enough time. Now, topic exercise. This is the one. Let me see here. Now, let's do it one by one. I will tell you something in which it is not yet taught. I will skip it. For example, detergent, aspirin, or a condensation polymer, right? For those three parts, we will have it next week. Now, take a look at question one. Take a look at question one. Can I have the answer of all those participants here, right? Each of you have a chance to speak up or write down something on the board and let me know your understanding. Starting from the very first one, Zhang Gaowei, question one. Chemists use knowledge of forces between molecules in ions to explain why different substances they are soluble in water. Which of the following statements is correct? Oh, Zhang Gaowei, or left again, Wang Zhenhei. C. Now take a look on the term C. Do you agree? C. He just mentioned C. Agree? I just want to get a pen. Get better pen. How come? Oh. Can I get a pen? How? How? So strange. Not C law. Yeah. C is not correct. And form hydrogen bond. This sentence is not correct. Indeed, it's not hydrogen bond. What is that? Attraction. I just told you yesterday. Yeah, very good. It's ion dipole attraction. Okay, it is a very good indicating questions telling us that Hong Jinghan was in the lesson yesterday, last night. So C is not correct. Which one? So what is the answer? Yeah, good, correct. How about B, number 2? How about number 2? How many stereoisomers are there? Stereoisomers. C is not correct. Question number 2. How many stereoisomers? Just circle it for you, huh? Now, okay. Question 2. How many stereoisomers are there? Chen Qinghei? What does it mean by stereoisomers? We have got 2 types. No? Stereoisomers. It tells you they have the same connectivity of atoms, they are in different arrangement in space. So there are 2 types. One is cis-trans. The other one is enantiomers. So you have to consider both when you come up with these questions. Anyone who can tell what is the answer for question 2? A. Agree? Anyone who agree? B. B. I can see some of you answer B. B. 4. 4. B. Yeah. B. But not A. Why? Now for this part we have got cis-trans, right? Because that carbon of the CC double bond, they are connected to 2 different groups of atoms, right? Can you see that? So we have got 2 stereoisomers already, cis-trans. But if you cis-trans, what do you mean by that? What does Chen Qinghei mean by that? Cis-trans. What is that? Now, how about this? How about this? So you may see the carbon here. The carbon here, what is that? No. What is that? Yes, this is chiral. So what does it mean by that? We have got cis isomer with that carbon which have a mirror image. So altogether, we have got 2 cis isomers, but we have got that chiral carbon, they will have 1 mirror image of the other, right? As the another enantiomers. Similarly, for trans, we have got the mirror image of one from the other again. Okay, so altogether we have got 4. Okay, is that clear? So this is question 2. Understand? How about number 3? How about number 3? The structure of a compound is shown below. Now, indeed, what is that? It is one type of fats and oil. Now, second bond, do they form cis-trans as well? The answer is no. Why not? That carbon we have got that is connected to 2 hydrogen atoms, which is identical. Okay, how about number 3? Number 3, how many cis-trans isomers does this compound have? I give you one more chance, Chen Qinghei. How many cis-trans isomers? Now, if you want to talk about cis-trans isomers, you focus on what? First of all, spot the CC double bond, right? Second, and trying to see if the CC double bond with that substituent they are of the same groups of atoms. If they are totally different, you may have a chance of a cis-trans. Yes, the answer is 2. Question 4. Question 4. Which of following compounds is chiral? Chao Hei, what do you think? Chiral. Why is this so strange, right? Yeah, D, that's right. This one is chiral carbon. Can you see that? This one is not, this one is. This 1, 2, 3, 4. 4 groups of atoms are different. Number 5. How come the net connection have got some time lag in here? While have a better connection at night. Oh. Take a look on question 5. Take a look on question 5. Carbonyl compound has distinctive smells, and methane has a smell of peppermint. Methane may react with two-step synthesis, where I like to add hot acidified A+ dichromic ions. A second, your resulting mixture is then added to NaBH4 in water. So what is that actually? What happened to the smell of the reaction mixture during the process? So step 1, A, yes, all right, remains. Why? How come it remains? Step 1, what is the reaction? What is the reaction for step 1? Yes, no reaction, actually, no reaction, because it is a ketone. Ketone cannot be further oxidized, so no, which means methane is still here. If methane is still here, which means you can still smell. Okay, can you get a point? So how about step 2? Step 2, what is that reaction? What reagent is it? Now it is a reducing agent. So it will reduce the ketone back to what? Now these they are similar and keep this as go back to alcohol. While this one we also have a smell, but the smell is not the same as the peppermint. So the smell of peppermint is lost. This one is correct. So the answer is A. Question? Yeah. Take a look on question 6. Alcohol X is resistant to oxidation by acidified potassium dichromic solution. What is the structure of a compound formed by dehydration of X? This one, due to dehydration. So what will be the possible answer? Now, you have to take a look on this very important sentence. Resistant to oxidation by acidified dichromic. So what is the hidden message? What is the type of alcohol? Yes, that's right. It refers that it's the tertiary alcohol. So you are going to think it backward. Which one will form a tertiary alcohol before dehydration? So how you get this? So simply you are going to think it backward. Now, because for that double bond to be treated, I would like to have a hydration. Hydration. Okay, so what is the hidden message of hydration? You're going to add back H2O into these that 2 carbon. One will have got H1 of that OH. Okay, so C, is it the possible? Now take a look on C. Somebody say C. Now this is the one. Now so this carbon is tertiary alcohol. So the answer is C. Of course, you may think of this OH and H here, right? But this one we have a chance of having the dehydration product like this. Question? Now, but for the others, no matter how hard you try, you cannot get the tertiary alcohol. For this one, we have got a chance. So C is the correct answer. Anyone who have doubts? Anyone who don't understand? Let me know now. Great. Question 7. The molecular formula of X is this. There's 2 carboxyl group. How many isomers may X have? Molecular formula of this. 2 hydroxyl groups. How many isomers? And you need to draw, right? You need to draw. You need to draw the different combinations. So C4H4OH. So 2 hydroxy group. So which means you have used up that 2 hydroxy group. Chen Kei said D. So tell me the isomers. What are those isomers? So remaining 2 carbon, right? You miss out 2 carbon. What else? 4 hydrogen and 2 H, right? Cis trans, yeah, cis trans. Think of cis trans. So what is that? You may be having like this, right? COOH. This is trans. We've got cis. So what is the answer? Is D? Sure? Sure? How about this? How about this? Does it show C4H4O4? Still yes. Okay? So it's rather tricky. For question 7, the answer is not D, is C. Okay? Number 8. How many chiral centers does the methyl have? Here. How many chiral centers? Can you mark the chiral center on here? Who draw that arrow? What else? How many? This one. Is it chiral center? Is it chiral carbon? Now, how many groups are there connected to the first group here? Second, 3 and 4, they are the same. So this one is not chiral. This one, yes. This one, yes. 2, the answer is 2. The answer is 2. 3, which is the third chiral center? Now, for these 2 is not. For these 2 is not, right? These, of course, not. These is not. We mean about this, right? Because we have got methyl, H. Well, the third group is CH2. Third group is still the same, right? But you will take a look on the second carbon that has connected to OH. And second carbon, no OH. So which means these 2 groups, they are not the same. Okay? You get the point is C. Question 9. Question 9. Consider the following blah, 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 right? Very similar to what you have attempted these days. Question 9. What is the answer? Now you take a look at the word major organic product. Major organic product. So for this part, I would like to add what? Yes, that's right. I would like to add hydrogen to where? To here. Hydrogen should be here. And then chiral group here. Okay? And leave it a single bond. So by doing so, you may get these 2 there correct. And later on, I do hydrolysis. It's hydrolysis. I replace the chlorine to hydroxide. So for B part, it's totally not correct because I cannot change the position. Okay? And how about Q and R? It is an oxidation, right? Oxidation, substitution, addition, right? For that 3. So you may get this one. So the answer is A. Got it? Question 10. The compound shown below is found in cocoa beans and chocolate. So, which of the following functional groups are present in a compound? Wow. 黃家豪 amide, yes. Can you circle amide for me? Where can you find amide? And then You don't have ester? How about amine? Where will you find amine? Yeah, this one is amine. This one is amine. So what is that amine? Now it is functional group. So what is the amine actually? What is the type of amine? It is tertiary amine. Can you see that? This one, this group, this and this group, they have got the 3 substituents. Okay, it's tertiary amine. How about 1 and 2? Now somebody who will find it quite hard to you may find it quite hard to see the way to see the amine, right? Ester, of course not. Ester is COO group, right? How about this amine? This is amine. This is all another amine. Okay, so what is the difference between this amine and this amine? Both are amine. We call that N-substituted amide for this. How about this? Now the N group, they will no longer have any hydrogen directly into this. So we will call that N, N di-substituted amide. Okay? So amide, we have got the structure like this, basic structure with this. So it depends on the substituents to add it to tell different types of amide. So first one, if you have got this one is both hydrogen will be found here. So we will call that nitrogen will not get substituted. For those amide, we will call that unsubstituted amide. Okay, so what is mean by substituted amide? So you are going to put this hydrogen into alkyl group. If you circle this, can you say that it's ketone and this amine? Can you get the point? Right? So the way to take a look on amide should be CO double bond connected to NH group. Okay? If you write it down, this one is amide, how would you distinguish this and this? So you just ignore the other 2 groups, which will tell you it is amide. Okay, so this one it is unsubstituted amide. It's N substituted amide because one of the originally put hydrogen is now go to another group. But for this one, it is N substituted amide because this nitrogen connect to no longer to hydrogen. We have got alkyl group. Okay, so what is it? It's just part of the amide. Okay, so we will go to number 11. Which of the following statements concerning aspirin are correct? Or something that it should be skipped because you don't know the structure. I will skip it for next chapter. Concerning soap, skip it. This one, skip it. Skip. These 4, 14, 15, and 16. Take a look. 14. Ethene exhibit cis-trans isomers. No, why not? Why not? For this part, they are connected to the same groups of atom, right? So they will not have cis-trans. No. There's free rotation about C double bond. Correct or not? Also wrong. CC double bond, of course, whenever I've got this, okay, so we have got a second bond which restrict its rotation. Only single bond can rotate. Okay, so there is no free rotation. No free rotation. It's cross, cross. Here comes the answer D. How about 15? Propane 2O is optically active. Propane 2 contains chiral center. Propane 2O, how do you draw this? Propane 2O. Is it optically active? No, because no chiral center. No chiral center. D. Yeah, both wrong. D. The last one. Both. This one tertiary butyl alcohol and this one can react with acidifiers. Both can react. Cross. Both have the same functional group. Yes. C. Okay, is that clear? You will find it difficult. Yes, that's right, tertiary alcohol. Because I've got 2 more minutes to go, I show you one conversion questions and we'll stop the lecture today. Okay, turn to question 30. Question 30. Question 30. Pencil, you need not write so much about this. I know that's you. Question 30. Outline a synthetic route with no more than 3 steps, or maybe you know, to accomplish the following conversion. For each step, give the reagents, reaction condition, structure of organic compound. This one. Do you know how to solve? Now, the similar question that we found on question 31. Can you see that? Now, you may find that. So what is the hidden message? You are asked to be quite aware to think of this, right? The ring formation reaction. Yes, that's right, ring formation. How will you know? Again, I count, right? If I go into count a carbon, it's carbon 1, 2, 3, 4, and 5, right? How you count it here? 1 is here. 1, 2, 3, 4, and 5. So this is ester. Ester, what is the chemical before ester? So what is the chemical before ester? Yes, that's right. So you may get like this. We're going to draw something like this. And then we've got acid, right? Acid here. And leaving here, OH. It's not H, it's not H, it's methyl. It's methyl. Can you get the point? COOH here, and this one OH. Only by having this do we get, yes, that's right. So what is that? What is the condition? Consol and heat. And you may get this. Heat under reflux first. Which one? Which one will you tell? First step, you mean? Hey, you mean first step? Yeah? First step. Yeah, sorry. NaOH, heating under reflux. Alkaline hydrolysis, yes, that's right. So the product will be OH and then OH and O minus, right? O minus, you are going to add acid, remember. You are going to follow by adding acid. Only by doing so, you can change this part to acid and you do the same action, okay? Can you get a point? So of course, somebody, yes, that's right, you may use acid hydrolysis and you save it. So you, if you write down alkaline hydrolysis, remember the acid one. If I use acidic hydrolysis, you can also get this. But if you want to talk about percentage yield, you use alkaline hydrolysis. Is that clear? So I will just stop it here. The timeline is 2:07. I'll stop it here. I give you some time to have a revision, and the quiz will start soon. Okay? See you. Bye.